Excellent. Okay. So yeah, my part of this is to this workshop is to give you a brief introduction to the virtual project, where the activities that we will look more into in detail today is has been developed. And those of you who were in the virtual Oscar workshop on Tuesday, you can zoom out now because this is the same content. So in 5 minutes time, it's time to zoom in again. So for the rest of you that are not so familiar with the virtual project, the full title of that one is Open Access Virtual Testing Protocols for Enhanced Road User Safety. It's a EU-funded project with a duration of 4 years, and we started 2 years ago, and we are in the middle of the project now. We have nearly 7 million euros from the Commission, and we are 15 partners from 9 countries in Europe. We have formulated our main efforts here into three aims, and that is to reduce loss of life and health in road crashes for all road users, share and foster knowledge, and doing that by develop everything that we do in open source, and identify the best protective innovations by adding virtual testing to the physical testing that we are doing, using open source human body models of both the female part, representing both the female part of the population and the male part of the population. The reason for addressing both males and females, in addition to that both part of the population is part of the population, is that we see from in-year statistics that for both disabling injuries and severe and fatal injuries, we during the same crash configurations, we have a higher risk of injury for females than for males. So in order to ensure that we address the whole population in our assessment of safety and in the development, of course, also, then models of like this are needed. We have a broad international collaboration in this project. We have both an advisory group and international partners that we collaborate with that have assigned to contribute to our what we do and where we have close dialogue. And here on the map you see those that has a specific role and have taken on that commitment, both from Canada, from US, different countries in Europe, from Japan and from Australia. And this is a mix of, as you see, institutes, companies, and academia. We have a vision that by 2030, in-year protective performances of new cars will be assessed for both men and women. And as I highlighted before, the benefits of this is, in addition to that we have done an inclusive crash safety assessment, we also are able to identify the best performing innovations which in new cars, which is not the case today. Now today we have to wait for 10 years for in-year statistics to be able to do the analysis, and then of course we are 10 years down the line in terms of the innovations, and with an expanded safety assessment, then you get a robuster systems, and which improve the safety for everybody. The virtual project is organized as you see here on the slide. We have one work package where we develop the OpenVT virtual testing platform, where we have the test protocols and so on. The second work package is where the human body models called the VIVA Plus models are developed. And then we have 3 different work packages, each for a specific road user and loading case. We have occupants in vehicles, one work package, pedestrian and cyclist in another work package, and we address standing occupant in public transport in work package 5. In addition, then we also look at cost benefits of the suggested solutions that we will address in this project. So with that, I hand over to the next speaker, which would be Johan, right?
Yeah.
Thank you, Astrid. So let's see, I think you need to stop sharing first.
I will do that.
Yes, and then I can share this screen. Can you see my screen, the correct one also?
Yes.
Yes.
Good, thank you. Okay, so I would start by saying the same as Astrid said. If you attended the workshop 2 days ago, you have seen some of my slides. I have added a couple of more slides and we'll talk slightly more about each slide. So you can choose if you would like to zoom out or not. So first of all, I would like to start with putting the human body modeling into perspective of the project aims. So we have some specific project aims that directs the development of the open source human body models in work package 2. So within the whole project, we have undertaken to create models of average female and average male in both standing and seated positions. And we will use 3 test cases to demonstrate the virtual tool chain and the injury frequency that we seen in those load cases, and that has just been published at Arcobi this year, will implicitly direct the focus areas of the human body models that I will show you later. So these test cases are seated occupants and whiplash injuries. And we have a second one that is protection of vulnerable road users, and that is pedestrians and cyclists. And then we have the third test case that is full initiation of standing occupants in public transports. We also have another aim here, that is that the open source human body models should be prepared for further development in other test cases that need to be addressed in future projects. And something that is not written here is that we also consider, at least when it's possible, the possibility to later on maybe translate this into another code. So where it's possible, we use material models that are easily translated into other codes. The first step we needed to do here was to define what is an average female and an average male. And this might feel very trivial, but it's actually a non-trivial task, even if we just consider stature and body mass. So depending on what population you have as interest, this average can actually vary quite a bit. And in addition, these numbers, these averages will change over time. So after long discussions, we decided to use the recommendations of the Schneider 1983 study, which is the foundation for the current human body models and crash test dummies. So one important upside with this choice is that the models, the average models that we create now can be directly compared to what is available today in terms of other human body models and crash test dummies. A downside, on the other hand, is that these anthropometries that we now use to create the human body models will not directly correspond to any current population. We can, for example, here, let's put on the laser pointer. We can, for example, see here that we have the word population, which is here for the male, this dot, and for the female down here, compared to what we're using here and here. So you can see that the world population is a bit smaller on average than what we are creating. And if we look at the current US population, the NHANES 2011 to 14, those are about the same stature, but they are a bit more obese nowadays in North America. So the model that we're developing are not really representative of modern North Americans either. So in addition to the Schneider study, which defines the mass and stature, we also decided on an age to use for the model. And here we decided to use 50 years of age, which is the average age of European adult population. Traditionally, human body models have been developed using medical data, and that can be CT, MRI, laser scans from a single person. This person have been selected to be close to the anthropometric of interest, for example, the average male or the average female. However, when this person has been selected, only gross anatomical measurements like stature and weight are normally used. And this means that there is no guarantee that this person is average in a general sense, for example, considering rib or pelvis geometry. And actually, if you attended the workshop 2 days ago, you heard that Toyota is now updating the thumbs model because apparently that person that they used to scan, the pelvis size of that person was a bit small, and therefore the model was a bit prone to submarining. So that is an effect of selecting a specific individuals. You don't really know if the person is average in other aspects than the one that you're checking, obviously. After that, we come to the second and most resource demanding step, and that is to generate the finite element model. As you all know, human geometry is very complex and it's time consuming to generate a really high quality 3D mesh. Preferably you want to use hexahedral elements. After this, the model needs to be validated, and it is important to validate the model for its intended use. So for example, the original VIVA model was intended for evaluation of whiplash injury in rear end impacts, and the majority of the validation effort was therefore focused on the head and spine kinematics and also kinetics in rear end impacts. After that, we have the end users, and they have their issues, and you get feedback, meaning that you need to update the model, enhance the model, add additional validation and so on. And all this must be carried out for each model or each anthropometry that is created. So if we look at the thumbs and the GHBMC families, this consists of the small female, the average male, and the large male. And they are available both as seated occupants and standing rear view models. So this means that you have a lot of models that you need to update and validate. In this project, we do it a bit different. So with the help of our friends at Amtri, we instead use geometries that are averaged over a population to start with. So in addition to the outer shape, also the geometries of the ribs, the pelvis, the femur, and the tibia of population averages. Where we don't have any data, we are using the geometry from a specific individual, and that is the same as was used for the original VIVA model. So then we create one base model, and we have chosen the seated average female as base model. And the reason for choosing the average female model is partly technical, but also political. And we think that it's time to put the females in focus, and to use the average female as the base model is one way to do that. Using mesh morphing, we then create what we call derivative models. Here we see the standing female and the seated male. And the difference between the base model and the derivative models is mainly the node file with the nodal coordinates. And this means that when it's time to do bug fixes or model enhancements, these changes just need to be implemented in the base model. So morphing human body models to other anthropometries, that is not something new. Basically, what you have to do is to define landmarks expressed as coordinates on your source geometry, which is in our case the seated average female model, and then the corresponding corresponding landmarks on the target geometry, which in this example is the seated average male. And this will tell the morphing procedure how these landmarks should be moved to create the male versions. And you would do this for a rather large number of points, basically on all the structures that you want to control. And then the points in between will be interpolated based on the closeness to the landmarks. As you can see in the figure, we have landmarks not only on the outer surface, but also on some skeletal bones. And this is because we have information of how the geometry of these bones change when morphing from a female to a male. And then the rest of the bones are just scaled based on the surrounding landmarks, at least in the current implementation we have. If morphing human models to another anthropometry is not new, morphing seated models to standing model is, on the other hand, not so common. And one major problem when doing this is that mesh distortion in the soft tissues around the joints that experience large rotations during the transform is very common. The VIVA Plus base model is created from scratch with mesh morphing in mind. So we have tried to orient the mesh flow to minimize the area with poor element quality. However, this is still work in progress, and we don't know how well this will work out in the end. So when morphing from a seated to a standing model, we will use the landmarks on the whole skeleton in the morphing process, as we want to make sure that the skeletal geometry remains constant. As in this case, we want to create a standing model of exactly the same average person as in the seated version. So currently, the derivative standing model is created by running a morphing script for about 15 minutes. And then we have to spend around 4 hours in a manual process to improve element quality, and in particular, depenetrate all the contact definitions again. And the end result is a new node file with the coordinates of the standing model. And again, the only difference between the base model and the standing derivative is the node file. Some part of the models are modeled in greater detail based on the injuries we want to be able to estimate. And these parts are the legs, including the knees, the rib cage, and the pelvis. And here we aim for strain-based injury evaluation, meaning that the element discretization must be rather refined. The cervical spine was already detailed in the original model, VIVA model, and has been carried over to the VIVA Plus model. In addition, we are trying to build the model as simple and robust as possible. And this means that we're trying to avoid, for example, tight contacts to hold the model together. And instead, we try to use mesh connectivity to connect parts. And an example can be seen here with mesh connectivity between the femur and the surrounding flesh. This means, of course, that meshing is much harder and take more time, as basically the mesh will flow throughout the whole body. And we still have some areas where we want to improve the mesh quality, and in particular the armpit area and the lower arms. The base model and the standing derivative model of the female are now finalized for beta testing. So far we have mainly focused on model robustness. As being an end user, I started my career with 10 years of being a consultant. I know that if I would get a model that just crashed directly when you start it, that will make me not so friendly with that model anymore. So I think this is very important to get an acceptance, early acceptance of a model. From the left here, we have a driver in the frontal oblique crash. In the middle, a rear seat passenger in the front crash. And to the right, we have a driver in the side impact. These load cases are rather severe and are meant to test the model robustness rather than its biofidelity. So finally, I want to emphasize once more here, this is like a generic version of how our file structures looks at. So if we start with the base model here, the seated female, we have some include files describing the parts, the materials, stuff like that. And then we have all the nodes in one file. So these are the nodes for the seated female. After we do the morphing to create the male derivative, the only file that will change is the geometries of the nodes. At least currently, we will also implement some other changes, material changes, for example, where it's needed. And we'll most likely use that using the star parameter setting in LS-DYNA. But so far, this is the only difference. And yeah, with that, I conclude my part of the presentation.
Thanks a lot, Johan. Thanks for presenting that. And later on, when we go to the Git session, you will even receive them all, and you can have a look at them all on your own. And now I would hand over to Arne.
Yeah, thank you very much, Corina, and thank you, Johan and Astrid.
Johan, you're still sharing your screen.
Yeah, I know. I'm looking. I have so many programs started here, so I'm looking for.
That's the window. Share my screen.
Oh, here it is. Stop share. Thank you. Sorry.
Sorry.
Okay. You should be able to see my screen. Is that correct?
Yeah, works fine.
Yeah.
You see my slides? Okay. So now I'm gonna present you a few things about the OpenVT platform. So as we've learned before from Johan's and Astrid's talk, in virtual we're actually creating a bunch of very useful things, not only state-of-the-art human body models, but also a whole ecosystem or universe surrounding them, such as models, test protocols, and so on. And what makes these things particular is not only the state-of-the-art modeling technology, but also the fact that all of these are going to be available free and open source. Now that means not only that any interested person or institution can just go and download the models and tools free of charge and use them to their convenience, but it also means that people can actually have full access to all source codes. They can modify the things, they can customize them, they can even develop them further, and eventually they can even take part in the development process and actually provide their own developments and modifications to the general public. Now, saying that the virtual products are free and open source while they just sit on your computer somewhere is one thing. Actually making them available free and open source is another thing. And in a project of the size of virtual, that obviously takes a dedicated infrastructure, and that is the OpenVT platform. Now, OpenVT stands for Open Virtual Testing, And the OpenVT platform is nothing less than virtual stored to the outside world. So conceptually, the OpenVT platform has mainly 3 functionalities. First of all, the OpenVT platform is basically a development platform. So the virtual project members and their collaborators from outside the project actually use the OpenVT platform as their workbench. So that is where the models are being developed, and that is where important functionalities for collaborative development come into the game. On the other hand, the OpenVT platform is also a dissemination vessel. That means the virtual models and tools are actually brought to the global user community directly from the workbench. Then the third pillar is actually sustainability, because the OpenVT platform is also going to be the base for the availability of the virtual products after the project duration of Project Virtual. Now to the technical implementation. Technically speaking, the OpenVT platform is a GitLab server hosted by our project partner Dynamo Nordic. The reason why we chose the GitLab framework is because, in our opinion, that is the state-of-the-art framework for collaborative open source development. It's also widely used in that community, so that's why we chose that. You can browse to the OpenVT platform on virtual.openvt.eu. I guess most of you actually already know that, and you already know this login and registration screen. And I guess most of you have registered in the meantime. And there you also have a few links to public contents, manual and guidelines, and so on. Now let's have a closer look at some administrative features of the OpenVT platform. Now, for the user level, any registered user is actually assigned a user level. There we are using the features of the GitLab framework to reflect our project structure. There's 3 different user level. The external user level is basically for the non-project members, so basically any community user around the globe. Then the internal users are essentially the members of the virtual project members, like of the virtual institutions. And then there's a number of admin users. That's basically those who keep the whole thing up and running. Now, similarly for the content organization, we're also using the features of the GitLab framework in order to reflect our project structure. Any content is organized in projects and groups. Now, project has nothing to do with like the virtual project. It's only a name for this structure of GitLab. A project is the actual repository where the any particular code or model or whatsoever is shared there is actually being stored. A repository is always subject to the Git version control framework that we're gonna learn later in the workshop. Now, a group is a structure that somehow takes several repositories with related content and somehow organizes them so the content, you have a better overview of the content. Then any content on the OpenVT platform, any group or any project has a visibility level. There's 3 different visibility levels: private, internal, and public. While the private and internal levels are mainly used for our internal development content, the public content is actually visible also to external users and also to any person on the internet. That's why we've implemented an additional hurdle for going from internal to public. We're doing a quality check in order to make sure that actually anything that is publicly available on the OpenVT platform meets our dissemination and the quality standards for public content. Now, how do you actually work with the OpenVT platform? Now, there are several ways of doing that. First of all, of course, there's the classic top-down workflow, how, for instance, proprietary software mostly is being developed. That means a group of developers, that is the members of the virtual project, are working on some content, for instance, find an element model or something like that. And then once they feel like this content is ready for the world, then they're disseminating that, they're offering that for download for the global user community. But what the OpenVT platform can do is actually more, because the users can, the community users can actually go and make local copies of any of the repositories. They can actually do their own working copies, which are called branches. That's all things that we're gonna learn later in the Git workshop. And now they can start working on that. They can modify the contents. They can actually customize the contents and even develop them further. But they can even do more, because once a community user now has a great new feature implemented into one of the contents, or just some bug fixes or whatsoever modification he or she thinks is useful, they can actually offer that back to the developers. They can submit a so-called merge request. And if that modification seems any good, then very likely the developers will happily accept that and make it available as a part of the generic version of the content on the OpenVT platform. That means this is a truly community-based approach. Actually, the user community as such can work on can take part in the development, can fix bugs and so on. And that is actually what makes the open source approach so powerful. And actually the user community is really fully integrated in the development of the contents. And that's what you can do on the OpenVT platform. Now that's also why we need you. So we would like to invite you to participate, to join the virtual developer community around the globe, and help us to make the virtual models evolve into something truly useful for safety assessment. Now let's have a quick look at public contents which are already available on the OpenVT platform, or which will be available within the next few months. So for the moment, that is essentially the original VIVA model and a cost-benefit analysis tool. But within the next couple of months, or even next couple of weeks for some of the contents, there will be a bunch of very interesting things, not only the first release of the VIVA Plus models, but also pre-crash and post-processing tools, several different seed models. So that will actually become within very short an extremely interesting set of tools for anyone working on road safety assessment. So, and now that's the point for you to become active. On this, on the slides, that on the Menti survey that Corina showed before, you can actually vote for the most interesting contents for you. So I don't know how we do that best. Corina, can I just click on this Menti? Oh yeah, so there you have already voted, some of you. So it seems that of course the VIVA Plus models are very popular, but there's also apparently a big interest in seed models and also the post-processing tool. So, oh, and it seems like also the original VIVA model is actually very popular. So all these things will be available within very short from now. I would like to encourage you to surf to the OpenVT platform every now and then and see already. Now it's the question, where can you learn more? And of course, you're going to learn a lot of things about how to use the OpenVT platform later today. But you can also, for any question, surf to the OpenVT wiki. that is located in the manuals and guidelines section. And there you basically find answers to most technical questions around Git and around how to use the platform. And for any question that you don't find an answer to there, there's also an issue tracking board here. You can submit issues, and that's basically meant for you to ask any questions to the platform administrators. And we will contact you very soon for any problem that you post there. Yeah, so then thank you very much for your attention. And I guess now it's time for the introduction to Git by Jobin. So how do you do the unscreen?
And thanks to all speakers, we're nearly on time. That's awesome. We had a rehearsal a few weeks back where this didn't work so good, the timekeeping.
Okay.
Hello. Yeah, thank you, Arne. I'm going to share my screen here now. Well, that's not easy. Okay, I lost my Zoom controls now. Screen. Okay, I hope.
Yeah, we can see your slides.
Oh, that's good. I was not on the first slide then. Yeah, that's good. Yeah, thank you. Yeah, if you can look at some of the more practical things now of what Arne and Johan just shared. And my name is Jobin, and I'll be helped by Martin today. Martin is from TU Graz, and he will be doing all the background stuff to keep the hands-on session running smooth, and he will act as the maintainer of the toy repository we'll be practicing on today. And of course, Arne Corina would be helping with ironing out the Git issues during the hands-on session. A few practical things before we start. We'll be using some of the Zoom features to make it smooth for us during the workshop. So if you click the participants list at the bottom, you will have few options like raise hand, yes, no, go slower, go faster. So when we have yes or no questions, I would appreciate it if you can reply with a yes or a no. And since this is going to be a hands-on session, and if you have to go away from your computer, I would appreciate it if you can indicate by the coffee mug that I just clicked, so that we know that you are away from your computer. Yeah, so let's jump into the session. If you were at the virtual workshop a few days ago, you may have seen this definition of open science. Basically, what we are trying to do with VIVA plus models, it's doing open science. So this is a nice definition from Forster EU Open Science Initiative. It says open science is the practice of science in such a way that others can collaborate and contribute, where research data and research processes are freely available under terms that enable reuse, redistribution, and reproduction. So coming to the VIVA models, the original VIVA model was hosted on a Chalmers web page. And the new one is hosted on the OpenVT platform, as Arne showed you. It's a GitLab instance. So now let's bring some of the keywords from the open science definition. So with the original VIVA model, the model is freely available. The reuse is encouraged with GPL license, redistribution also, free production. Since it's a static website and we don't have the analysis workflows available, it's not completely reproducible by anyone who gets the model. And since it's a website, just a website, collaborating and contributing back to the model is not possible unless you go to using emails or Dropbox, and they're not the best. And this is something that having the model on a Git server solves, having it as a Git repo. So it's freely available, reuse and redistribution encouraged. The Viva Plus models have lesser copyleft license. It's LGPL version 3, so that you can plug into proprietary models. And reproduction would be better, since we would be working on providing the analysis workflows through dinosaur libraries, and then collaborate and contribute. That's the main part, and the foundation of open source projects. And that's those are two things we're going to focus on into today's workshop. And overview of what we're going to do today. And before giving you an overview, it's important to understand that in order to contribute to open library, you don't have to be an expert or you don't have to be a core developer who has all the knowledge. It's that each person brings their skills to the library. So here, even basic users, they can be part of the open community by reporting issues or requesting features or being part of the conversation. And then if you use it and you have your own use cases, or you perform more validations, and you feel you can enhance the documentation, you can contribute it back to the community, and everyone can make use of it. The value of open source or open science is when you contribute back and others find value in it, and it triggers a positive value cycle. And then the issues raised by users, contributors, they are fixed by the developers. So there you will need some experience with model development, but otherwise everyone can be part of the user community. And these are just examples of how you can be part of the Viva Plus community. So some of the things we are going to look at today, how you can be part of the conversation. We'll be looking at GitLab issues. That's a really powerful tool to coordinate development and conversation. And then we have the use of Git repository to version control and saving. And we'll look at ways how you can save your work and publish them online, make it available to others. And then how, if you're developing the model itself, how you can work on a branch and then merge it with the master branch, which is the stable branch. Before we jump in, you might be interested to know the survey that you took part of. So we see that most of the users use LS-DYNA. You're in the right place. The models are developed in LS-DYNA. And we see that most of us use GUI-based post-processors. That's not great for reproducibility. So, but some of us use scripts. So that's something we're going to addressed in today's workshop. And you see there's a competition between Python and MATLAB here. But maybe putting together Python and R, maybe Jupyter wins. We're going to look at Jupyter today for computational notebooks, and looks like not many of us use computational notebooks in our research. So we hope that this will be a useful workshop for you. And going into the Git part of the workshop now, not many of us use Git. And even among those who use it, the familiarity with it is low. So this is all new to everyone. No one's an expert in the room, so feel free to ask your questions. There's no stupid question. So make the most of our interactive sessions today. So what is Git? Git is a version control system, and version control is a system that records the changes to a file or a set of files over time. The two kinds of version control systems. One is where the whole library lives in a central server, and then you check out the files that you want to update. You do the updates and push it back to the central server. The other kind of version control is where the whole library is distributed. Basically, everyone has a copy of the whole library, and everyone can push and pull between all of the copies. And this is a very stable and fast way of version control. We'll come to more of it later on. And this is a very safe way of collaborating where there's no single point of failure. All of us do version control in one way or the other. So this is a screenshot of my folder when we were developing the pre-alpha versions of the model. You can see how I ended up versioning the preprocessor files, and some of them crashes, and then I have to put an underscore to show that it crashed, and it gets messy after a while. And this was just me. And imagine if there's more than one person collaborating, then it becomes even worse. That's where we want to automate the version control, and that's what Git is for. If you'd like to have some more motivation to learn Git, this is the state of open source at the end of last year. And see that the largest number of contributors to, and this is a survey on GitHub, which is the biggest open source repository. And these are the unique contributors.
Yeah.
Was there a question? Okay, yeah, these are the number of unique contributors, and we see a big numbers from the big IT companies, Microsoft, Google, Red Hat, but we also see there are universities up there in the list, UC Berkeley and Intel and University of Washington. So this is going to be a key skill in the century. Open source is all around us, and it has become so essential that schools are now planning to include it in the curriculum for high schools. So how does a version control system work? The basic workflow goes something like this. You have a repository online or somewhere that lives somewhere, a central repository. You download a copy and you make updates. You save the updates and you upload them back. That's the basic idea, but to automate this process and to make sure that we don't have clashes, or even when we have clashes with other people's version, merging them and resolving them, that's the key point to having a efficient version control. let's take a look at the VIVA Plus repository. Maybe I'll stop sharing my screen and I'll post a link to the VIVA Plus repository on OpenVT. And assume most of you would have got guest access to the repository today afternoon. If not, you can let us know and we can give you an access to that for this workshop. Trying to share my screen here. So if you look at the online repository, so this is where the main or master branch or the main repository lives. This of the VIVA Plus, it lives on OpenVT. And if you look at here, you would see that these folders of files, they have something called commit messages tagged with it. It just shows the commit message or the message with which it was saved the last time and when it was saved. And if you look at the version history, you see how it was developed. It was developed in branches here and then merged to the master here in the run up to the beta release here now. And each of the save is called a commit in Git language. And you see here the commits that were made during the past year. And the good thing with Git is if you want to go to a particular commit, you can go back and start from there. There's an option always to go back, redo, or pick and choose from a particular commit. And each commit is tagged with a hash number here. It's alphanumeric number. And keep this in mind and we'll come back to it later. So a powerful feature of GitLab, having GitLab or even on GitHub, is having issues. We work with a issue-based workflow where the development is indicated through issues, and it's organized as a Kanban board to get a pseudo-agile workflow here. So these are open issues or things to be fixed or planned to be fixed in the near future. And these are things being done. And these are things, or when you start doing it, you move it to doing. And these are things that were done recently. So this is where you come if you want to raise an issue, report something, or have a discussion of some feature of the model. Now let's head into the exercise we have for today. The exercise workshop, or sorry, the repo, the exercise repo that you requested access to. I'll post that link to that also on the chat. Oh, I see a message from Karin that you can't see the repository. Maybe Arne, can you take care of that?
Where did you see the message? So Karin, you cannot see the workshop exercises.
No, the VIVA Plus, I think.
Sorry, I need to move my mic. Sorry, that I could see, but I wasn't able to see the repository when he was showing the VIVA Plus. I don't have that access, I think.
You should.
I can see project and I can see issues, but nothing else.
I'll check that you.
I think it's the same for everyone. That we're not able to see the sort of the models and the other stuff that you showed, Joan.
I see. Okay.
But I think if you click the link that Jobin John just posted, then you can see the repository.
So it seems like some of you.
Yeah, so for the workshop exercise, I can see the repository, but not for the VIVA Plus models.
Okay. So if you're not able to access your access the VIVA Plus repository, can you please indicate with a no on the participants list so that Arne can fix that? Okay, for those, while Arne fixes that, let's go to the workshop exercise repo and go to the issues and start a new issue saying that, okay, before that, let me give an idea of the exercise we're going to do today. We're going to create a list of all the participants in this workshop collaboratively. So it means all of us enter the name, each of us enter our name to the repository, and then at the end of the workshop we merge them all, so then you get an idea of how the whole workflow is in Git. So what you're going to do now is create a new issue saying add yourself. So I say add Jobin to the participants list. And since I'm going to fix that, I assign it to myself and I submit this issue. So anyone coming to this repository knows that I am working on this. If you click the board here, we're going to add defaults here. Since this is a new repository, we have some setup to do here. And then I'm going to fix that. So I move that to do, or maybe doing. I'm going to do that right now. So if you are able to do this and you finish it, please indicate whether, okay, we already have no's there. Looks like.
Just a question to Karin. Can you check again whether you can access the repository now?
Yeah, and all the others who weren't able to do.
Yes, now it works.
Now it works. Okay, then because before you had a guest permission, and now set Karin to reporter, so I'm gonna set everyone to reporter, and then it should work.
It's good. Okay, so you'll be getting access to it soon. But if you have created an issue here, please indicate with a yes on the participants list. Oh, I can see issues coming up there. Okay. I assume all of you are able to do that. Before we go into the break, maybe we'll look at some of the core concepts of Git, and then we take a break and then come back and do a hands-on session. So all of workshop instructions are available on the handouts that you received. I've put a link on the chat also. So you get access to all of the commands and all the workflow that we're going to follow today on that. So please keep that open in a tab, or if you would like to have it on your second screen, or if you don't have a second screen, it can be helpful to have that on a mobile screen maybe. I'm having troubles here with my presentation. We'll come back after the break and do the Git clone, but for now, to see how Git works, imagine if you have 3 files, H, P, and M, and then you make changes to one of them, or 2 of them, H1 and B1, and then you save them. So it gets saved as commit. So in Git language or Git lingo, a save is called commit. And then if you again change H1 to H2, it becomes a new commit. And each of the commit is tagged with a commit number at the top, commit 1, commit 2, commit 3, and that's the hash number that I showed you on the Git repository. And each commit is a snapshot of the whole folder, but it does not save unmodified file. It points to the last unmodified version. So one way to see Git versioning is that it's a series of commits with a commit number labeling that snapshot. And each commit points to its parent. So when you make branches, you're not making a copy of the whole repository, but you're making an update to the files you have that points to the last commit it branched out from. So coming back to the general workflow, we had the download and upload. In Git lingo, it's called Git pull and Git push. And the save action happens in 2 steps. In the first step, you add your files to an area called staging area or index. That's where you prepare the files to be added or saved. And then you take a snapshot of it and move it to the repository where you permanently store it. That action is called git commit. So you have 2 actions: git add, that gets the files ready to be saved, and then git commit. And if you look in your Git repository, you would see a hidden directory which stores all the past history and versions of the files. And there you would find the index and all the other Git objects. But the files that are visible in your folder, those are, that area is called the working directory. So when you are coming back and giving or seeing that in a different angle, when you're ready to save your files, you say, okay, I will save my files now. You basically stage them, you put them on a stage, think of it as putting them on a stage, and then taking a snapshot. That's git commit. So these are basically the two commands you need to know to work on a Git repository. As long as you know these two, you can make an excellent version controlling of your files. Okay, let's take a break now, and we come back and practice some of these using the Git installations we have done before the workshop. And if anyone had troubles with the Git installations, we are happy to stay back during the break to help you get it working. So we come back in 10 minutes. And that in European time would be 23 past 2 in the afternoon. See you after the break then.
See you in a minute.
Thanks.
Thank you. Is there anyone who wanted help with Git installation?
There is a question regarding the documentation.
The instructions, maybe we can put the link to the handouts again, or maybe I can give the specific section. I was having trouble sharing my screen. I don't know what's happening with my Zoom. I was thinking of putting in the link to the exercise we're going to do.
Jobin, can you hear me?
Yes.
Oh, hi. Can you send the whereabouts is the documentation? Because the link you send just opens the virtual VIVA workshop tab.
Okay. So I just put a link on the chat. Can you try that, please? So that takes you to the section we are going to be doing after the break.
Getting started with Git, is that right?
Yes, that's one we're going to be looking at after the break.
Thank you. Thanks very much.
You're welcome.
Sorry for additional confusion because I sent the wrong link. It's just it's like a web page, so you can go through the different topics on the left-hand side.
Sure, no problem. Thank you.
Well, we were going on time till I came in.
Like always, Jobin.
Yeah. No, just before the workshop, I remembered that I then put the survey statistics, and then I added that, and that I thought it would be interesting to see where others in the workshops are, so that no one's discouraged by the steep learning curve of Git.
I think we're still fine. You still have around an hour.
Mm-hmm. Yeah, I think we can do it.
It has to work somehow.
Mm-hmm.
So it will.
Open merging is going to be fine as well, because last time it took some time to update that.
Mm-hmm. Yeah, but we're going to go for a break after that. So I assume
we'll break after.
Martin won't be having a break then. I hope I can also help with the merging, I think.
Yeah.
So when you do the merging, Martin, I have created a list, an unordered list for the markdown. So if you can make sure that there's no blank space between two
Yeah.
hyphens, I think then we would get a good list.
Yeah. Yeah, we already have a branch, a new one by Matthias.
Oh, people are getting bored with the slides and start doing the exercise.
Yeah, I think so.
It's a good sign. Oh, that's the whole purpose of having the handouts given out.
Yeah.
Looks like Matthias took it from the issues itself. We created the branch from the issues. That's a good thing.
How can you do that?
Okay, so if you go to your issues, I can share my screen here. So let me take my issue here. And then you can say create merge request, and that automatically creates a branch for you. And all you need to do is check out the branch locally.
Okay.
So there are two options. Either you can create just a branch without a merge request. So then it doesn't create a merge request here. So this automatically creates a merge request for you. It automates that for you.
Johan, are you also going to talk a bit about the model documentation?
I thought I'll do it after the break when Martin is merging them.
Okay. Because I was thinking maybe Arne can show one slide just briefly explaining the license conditions, because I'm not sure if everyone was familiar to LGPL.
LGPL, yeah. Does he have a slide ready?
I think so. Arne, are you here?
He's gone for the coffee.
Yeah. But I was telling him in the chat that I realized while we were talking that this was maybe something that is missing.
Yeah, I mentioned it in passing when I showed the difference between VIVA and VIVA Plus repositories, that it's less copy left. But then, yeah, good to know.
Jobin, can you switch on your camera so that I can make a picture for Sanne? I promised to her.
Oh, is it just me? Then it's not going to be a good picture.
Yeah, but you're presenting at the moment.
Do you want me smiling?
Why? I can't see you.
Must have opened on the other screen. Zoom does that sometimes.
But I can make it on my phone. Can you do it again?
I'm I'm visible. My camera is turned on.
Cool.
Yeah.
Hello. Excuse me, this is a good moment to make a question.
Sure, yeah.
Hi, it's Miguel from U Waterloo.
Hello.
I was trying to install yesterday Ubuntu, but for some reason my Windows crashes every time I install Ubuntu and restart it. I have no idea why. But my question is it required, that to my understanding, Ubuntu is kind of another option to Git bash? Is that correct?
Yeah. So you're working on an Ubuntu, if I understand you right.
No, I'm working on Windows.
Okay.
But in some part of the instruction, it says that in Windows 10, I can add Ubuntu without having to have a virtual machine and so on.
Yeah, if you have like the WSL Windows, automatically does that for you.
Yes.
If that works, I think.
I think you can install it as an app if you go to Microsoft Store.
Yeah, that's exactly that's what I did, but that is not required, right? That is just one option to do it. Is that correct?
Yeah, by default you get out of the box in Ubuntu.
Okay.
But you don't need that because you can also install the usual Git bash or this Git extension. So I'm also working on we're more or less all working on Windows machines without an Ubuntu.
You can do that, but maybe you're as me. I hate Microsoft syntax. I like the Linux syntax.
Okay.
So ls instead of dir, for example.
Yeah.
And you show files.
Okay, thank you. That was the question. I was just wondering if this Ubuntu app was a requirement or I can get away with the Git bash. Thank you.
It was for the aesthetic guys like Johan.
Okay, great.
No, you can do pretty much everything using Git bash. And if you have the latest versions of PowerShell installed, I think it's the 7, then you can access Git through PowerShell too, and all the Git commands work on there also. So you don't have to have Ubuntu.
All right, awesome. Thank you so much.
Yeah, you're welcome. Okay, maybe it's time for us to start again. And if you're back, can you please indicate with a yes on the participants list so that I know how many you're back? Okay, that looks like a majority. Maybe it's time to start. So this is the handouts that I was mentioning before the break. So we have the workshop handouts in the same web address as the pre-workshop setup instructions. If you go to the left and open the tabs, you have a Git and a VIVA plus processing handout pages. That's most of the contents of today's workshop. And if you would like to explore some more of Git repositories in the world of biomechanics, then these are some of the things also that you may like to explore: OpenSim or Piper Child Model, and the FE Bio software. So let's go to the hands-on part now and try some of the things that you saw on the slides before break. So if you go to the next page and go down, we have exercise tab here, and you'll have all the instructions for the hands-on exercise over there. But before that, maybe it's a good idea to get an intuition of the Git workflow. I had a embedded page here, but maybe it doesn't work because I'm sharing my screen. This is a Git learning web page. Can you see both my windows?
Yeah.
Oh, that works. Okay. I have my camera here. Okay, and I'm going to use some of these Git commands here. And imagine that we're developing the lower extremity part of the FE model. And this is a ideal example where first we create the femur mesh. So when we were developing the femur, oh, I have a semicolon instead of M there. So the mesh was developed here at Chalmers, but TU Graz was looking at some of the validation of the lower extremity. So let's imagine now we develop the mesh here in Sweden. And I make two commits here, femur mesh and tibia mesh. And then TU Graz comes along and says, we would like to do the validation for the femur now. And they make a branch. So they make a branch, git branch, and make the branch name maybe femur. Femur validation, and say, and note the commit ID that we have here. That's 7026 DAE. And then you see a new tag was created there called femur validation that indicates that there's a branch over there. And then you're on that. You're not yet there on the branch. So notice something called the head here. A git head points to the place where your next commit is saved. So we would like to save our next changes. So TU Graz is going to work on that. And so they're going to save their work on the femur validation branch. So they need to move the head onto that branch. For that, you have to check out that branch. See. See the head moved there. So that means the next commit is going to be saved on the branch femur validation. Let's say for doing that, they're going to update some material properties. And there you see the commit went to the branch femur validation. And once they have done or completed their work, they decide it's time to merge to the master so that it's available to us too. And they would say git merge to master. That creates a new commit, merging it to the master. And then if you want to continue working on the master, move the head to master and continue the process. So think of head as something like recording head, maybe on a record or a CD or DVD. That's the point where you write to. That's the point where your next save goes to. That's where the point you commit the updates. Okay, now let's hope you got an idea of the Git workflow. This website is a good one to practice some of the commands. You get a few options here. With practicing with the remote, we're coming to this later part of the workshop. So I would recommend you to explore that. Let's come to the hands-on part of the Git section here. And the first part is to get a clone of the workshop exercise on your computer. For that, go to the location where you would like to have the repository cloned to. from the OpenVT, where it is right now. And what I do regularly is right click and say git bash here. That starts a git bash window here. And then I go to the repository that I want to clone and go to the clone button over here and copy the links. So here, please copy the SSH link because right now only SSH works with OpenVT, but in the future you would be able to use HTTPS also. Now go to the git bash and say git clone and the address that you just copied, shift insert because it's a bash. If you're working from PowerShell, then you can use the Windows Control V. Ask me for my password here. And it makes a clone to the folder. And here I have.
And it's the password of your SSH key, or isn't it?
Yes, yeah, thanks for reminding that. That's the password to the SSH key and not the OpenVT platform. I hope you still remember the password to the SSH key when you configured Git. So you can see here that I get the same contents here as the online repository. I have a directory called postprocessing and a README file. And this is the hidden Git directory that I mentioned to you. And this contains the objects. Like you might be familiar now with words like head, index. Coming back to the exercise. So as a first step, we're going to make a branch because we don't want to commit on the master. In most open source libraries, the master is protected. That means you can't write to the master branch. Only the maintainers can make commits, and then too, it's for hot fixes or small changes to the master branch. So it's a good practice to make all your commits on a branch. So we're going to create a new branch here and say git checkout -p and my name, because that's going to add myself to the participants list. Oh, so you see that it's not a Git repository, so you need to move into the Git repository now. CD. Now I am in a Git repository, and that I can see here by seeing that it's on the master branch. So it shows me that I'm the master branch, and I'm going to repeat the command here. So what this does is a combination of two commands. It creates a branch, git branch, and then git checkout. So I see a question from Karin here saying that you can't access the repository from git bash. Did it get cloned, or can you see the?
So when I put the git clone command, then I've been sort of guessing for passwords. But at some point, I think I might have done the right password, because then it says permission denied, could not read from a remote repository. Please make sure you have the correct access rights and that the repository exists.
I see. Okay, that maybe because you entered the password too many times, you may have locked yourself out. If you had this issue in the past.
Does everybody else? Can everybody else read it? Because then it's probably a user error on my part.
Maybe can you indicate with a yes on the participant list if you were able to clone? Did you use your SSH key under the user setting?
I probably did not. Where do I find that?
That is probably the problem.
Yeah.
At the SSH.
Where does it say how to do that?
The problem is that for now it doesn't even fix the problem anymore, because now you have been blacklisted by their server, and
okay.
Oh, sorry for that.
I apologize for being such a terrible student.
It's no problem at all. The problem is the server keeps you on that blacklist for 3 to 4 hours, and then the problem fixes itself, but only in 3 to 4 hours.
Okay, so I will just view the rest of your exercises.
In the meantime, maybe you can use. I'll send you 2 lines of code, and then you can use a different method, and then Jobin can just continue with the workshop.
Okay, perfect. Thank you.
Yeah, thank you, Arne. Yeah, sorry for that. I hope it works out. Yeah, so we get a branch now. We create a branch, and we have switched to the branch, and you can see here that it indicates that we are on the new branch instead of master. That means any future commits go to the branch. So now let me go to the repository here and open the README file. That's where our participants list is. And you can open it in any text editor. Now let's open that with.
We got the request that you should maybe decrease the speed a bit.
I see. Okay. Yeah. Thank you for. I didn't see the message. Yeah. We can read.
There are special problems. You can also raise your hand, and we can also organize a breakout room if there is a need to explain something more in detail. So feel free to make use of that as well. Maybe just, what was the raise your hand? Was it the thumb up, or was that it was not the coffee? Was it the clapping?
It's yes. We then. Okay, someone says it's fast. Go faster. Oh, someone's saying go faster. Or did you mean go slower? Anyway, if you have technical issues that you feel you're not able to solve, you can raise your hand. Then we can assign you to a breakout room where someone can help you with that. Probably Martin. But we'll take it a little more slower here. And
and one recommendation is maybe just to open the handout next to you, then you don't have to switch between Zoom and your window, because everything is also shown in the handout.
Mm-hmm. Yeah, and if you don't have 2 screens, maybe have it on your phone. It renders well on your phone. So if you have been able to follow up to this point where you create a branch, can you please let me know with a yes on the participants list?
Except Karen, who was blacklisted. That's really bad. We'll fix that as well.
And if you have already finished, feel free to go ahead with the instructions on the handouts. It's pretty straightforward. Okay. Guess again, go ahead with the next step. So I open the README file. That's where our participants list is going to be. But unfortunately, my name is already there on the list. Maybe I remove my last name. so that I can show something has changed. I save it, come back, and come back to the git bash. And now if you check git status, it says the README has been modified. So git status is going to be one of the most frequently used commands if you use command line to know what's the status of your repo. I get a comment from here from.
We'll create a breakout room.
Okay, I think I know what the issue is over there. I think you said git intro exercise, but the directory is called workshop exercise. Sorry for that typo there. So instead of cd intro exercise, if you can say cd workshop exercise over here, as you see on screen, that will help you over there. Thanks, Fabian.
So you were faster with explaining than I was with creating the breakout room. Sorry.
Yeah, thanks for that. We'll go to the breakout rooms for the more critical problems. Hope nothing comes up during the workshop. Okay, now the next step would be to save this modified file. So the command for that is git add, as we saw in the presentation. And then I say which file name. So you git add and then the file name. You can use tab completion and say git add readme. You could also use git add space dot period. What that would do is add all the files in your repository that are changed, but it is not recommended because then you would not have control over what you add to the staging area or the index. And that is the basic idea of having area as staging area or index, so that you can design your commits in such a way that you categorize your changes or categorize your commits so that you can come back to it or revert back to commits later on when you want to. It gives a good history of your repository. So adding them individually is the best practice. And after doing the git add, if I try git status again, says changes are ready to be committed. It says there's a modified file called readme, but now it's in green, saying meaning that it's added or it's in the index area or staging area. So if you have got till this point, can you please indicate with a yes on the participants list? A green yes. And it's fine if you're not able to complete it. We'll have some more time at the end of the next page or the next section where you can complete them. Okay, now it's time to take the files that you moved to the staging area and move them to you or save them to your repository, store them permanently. So for that, you would use commit, and every commit message should be accompanied by a commit message. So you slash. That says changes are committed. And if I check git status, it says I'm on branch Jobin and nothing to commit, and working tree is clean. That means the working directory is clean. It's all committed. Any questions so far? Anything that was not clear? Okay, maybe we should move to the next session where we move push it to the remote repository, and then we have a bonus exercise there where you will have an extra time to cover this if you're not able to do it. Let's go to the working with remote repo section. And here you would learn how to push your updates, how to submit merge requests to merge your update with the master, and also how to pull the updates to the repo back into your computer. So now let's say we're going to push this branch to the OpenVT platform. The command for that is git push, and the remote repo here is called origin. And you say push to origin, and your branch name is your name or whatever you call it. In my case, it was Jobin. And ask me for my passkey. And says the branch is now pushed. So that means now it's available online. So if I go to the workshop repository now, and let's look at it now. This is still the master that's showing up. But if I go here and see, we can see that a few people who pushed. And if I go to my branch, I can see I changed it. If I go to someone else branch, I can see that Alexandros added his name to Watson's list. Looks like the README file was not saved before you pushed Sujane. Maybe that's something for you to look. Yeah, well, that gives you a basic idea of how it works. Now going back to the hands-on exercise, you're going to do one more iteration so that you know how to add a new file. Looking for my handouts here. So we have a bonus exercise here. So the idea is you would add a new file to the repository and add that and commit it. Basically going through the whole same steps again and pushing your branch again. And after you have done that, you will submit a merge request to merge your branch to the master. So you're welcome to try this on your own. I will also be doing it. And if anyone has questions, please feel free to unmute yourself and ask your questions. So unless someone interrupts me, I'm going to walk through this example. So going to the repository here, and I'm going to create a new text file. Say, going to give my name, Jobin. Oh, says hi. And save it as a markdown document or text file. So change the extension to .empty rather than .txt. Well, you can have .txt, it doesn't matter. But Markdown is a markup language where you can render your text online. So GitHub and GitLab does it really well if you have it in Markdown. And that's the reason we have it in Markdown. And then I open that text editor here and maybe leave a message here. Let's see. Let's get this going. Say, let's get this going. And I don't know if that's funny. I save it, so I have that file here. I go to the command line and say git status, and says there's a untracked file. That means the file Jobin says hi is not tracked. So now we need to add it to the index or staging area first. I say add a completed using tab completion, and so now use git status here. It says changes are ready to be committed. So there's a new file that's tracked or going to be tracked, or the green indicates that it is in the staging area. And then before that, one more step here. I'm going to show you how a little bit of the Markdown language. So here, this one here is a heading 1, double hash is heading 2. This makes a list here, or hyphen, and if you want to make numbers, you can add 1 and 2. That's a list with a numbered list. In the VIVA Plus documentation that I'll be showing you later on, we have a helpful list of syntax for Markdown, and or you can search it online. It's available everywhere. So what I'm going to do here is I'm going to hyperlink my name. I'll link my name to the file. I see. And that I do by putting the text that I want to link within square brackets here. And within round brackets, I gave the name of the file that I want to link. So it's say hi.empty, and I save it. Getting back here, I check it's modified. I could have done both of them in one go. If I had modified this earlier, add them, I could have added multiple files using the git add, and then make a list of the files you want to add. But here I'm going to add readme and commit, and give a meaningful commit message so that your collaborators can know what is the commit about. Add a file linked to Jobin. Then I'm going to push this online. pushing it to the remote repo on OpenVT, and that's called origin, and pushing the branch called Jobin. So git push origin Jobin. Ask me for my passphrase here. Great. If you have been able to do the exercise till now, can you please indicate with a green yes sign on the participants list? No one. No one yet. Or if you didn't choose to do this exercise, the bonus exercise, that too is fine. But now we go back to the OpenVT platform where we had this repository. And if you have an interface like me, it says you pushed Jobin 8 minutes ago. Do you want to create a merge request? Either you can click over here or go to the merge request panel on the left and say create merge request and select the source branch, and that's my branch, Jobin, and to master. So there you go. And here for this exercise, you can assign it to Martin. He's going to be merging them. And for the approvers, if you type in a group of approvers here, or here, if you look at VIVA workshops, then any of, if you select the group VIVA workshops, then any of us maintainers on the repository can approve it. This shows me which commits are going to be merged and changes. And the changes made to the file. So it says the README has been modified and there's a new file. Say submit merge request. And I see this page because I am an admin on this repository, but you would probably not see this merge option here. And another thing before you do that is you can close your issue when you submit your merge request. So you can go to the, when you make an issue, or when you just before you merge, you can note your issue number here. It's number 2, and oh, I see that my merge request is gone. Otherwise, I can edit it, but you can add to the merge request. You can add to the title saying closes hash number or fixes hash number. That would automatically merge or close the issue there.
Martin was too fast for you, I think. Yeah,
he's really fast today. So now let's see what's happening on the repository. If you go to the graph here, you can see the commits made by the workshop participants today and how it gets merged to the Git master branch. Hope that gives you an idea of how Git works. And how we maintain our VIVA Plus repository is basically the same way. We make commits that are manageable or modular. And as we work, we keep making commits. And then when the branch is ready, we commit it into or merge it to the master. Maybe is it time for another break now?
Yeah, perfect in time.
When we come back from the break, we're going to see Git pull, and you can see how you can get your updates into, updates made by others into your repository. And finally, I would be showing you what happens to your working directory when you switch between branches. And then I would show a little bit of the VIVA Plus documentation. So we break for another coffee, maybe for another 10 minutes. We come back at 3:13 Central European time. That's 10 minutes from now.
And if you have any problems, we will be here during the break to help you. We don't want to frustrate anyone, so if anything has not worked, please just let us know. Sure, we can fix it together. It seems that we have a lot of experts on board.
That's really good.
So Karin, you finally got it to work?
More or less.
Yeah, that's great.
Now I'm getting some weird errors, but or some fatal errors.
Okay.
Because I have the wrong email address.
Oh, that is
my auto-detect email is not what it accepts, and that seems tricky to solve. But I got as far as adding, but I cannot commit.
Okay.
What is the error you get? Oh, the current?
I have a fatal email address.
Okay. The reason is when you make a commit, it tags it along with your email, and that's how the online Git repository keeps a track of who makes the commit.
Yeah.
So maybe what is happening here is the Git config. When you did the Git config, the email you gave didn't match with the email you registered on OpenVT. That's what's happening.
I haven't probably have not done a Git config.
Maybe that's the reason.
Can you do a git config -- list, what I just wrote in the chat?
I'll try.
Then you're getting a list of all parameters.
Oh, yes, lots of parameters.
Yeah, yeah.
Or I can just run the global user email that it was suggesting. Oops.
You can actually modify any of these parameters by always typing git config parameter value. So git config user.email, and then that always sets them. And actually that HTTPS verified.
Oh, it works.
It works? Okay.
Can I see the difference somewhere on the website now?
If you mean your commits?
Yeah.
You wouldn't see it on OpenVT unless you have pushed it.
Oh, so I need to push it. It's not enough to just commit it.
No, it still stays on your local repo. It becomes available online only when you push it.
So it's like committing is like saving it locally on your machine, and then pushing it is putting it to the cloud or the server or whatever.
And actually, I would recommend you to, after the workshop, do the following: do a git config -- global HTTPS SSL verify true. So you set it. You tell Git again to check the HTTPS certificate. You set that to false.
Okay. Yeah.
And I mean, I guess you're not using Git for anything else. So that's basically not a problem, but just to be safe,
No.
I need you to set it again to true. after the workshop.
Yep. Sure. So where do I find the instructions of pushing?
You have this page open. Or I can put this on the chat.
Oh, so that was working with the remote repro. Okay.
Yes, the next page. So if you're on this, you can click this to move to the next on the side. It's this one I show on the screen, git push.
Oh, there.
Origin and your branch name.
Was that my name, right?
Probably. So if you can,
I followed the instructions.
Then it should be a name, or you can see it on your command line.
Oh yeah.
Shown on the bracket.
Yeah.
That's the current branch you're on. And then maybe you can skip this for now so that you can see it on the, so that you can submit a merge request.
Oh. Now I get a pop-up window with Git Credential Manager for Windows, and they're your credentials. Okay, so then it's the login for the OpenVT, right?
You have the HTTPS. Yeah, then you get the login for the OpenVT platform.
Okay, I didn't know HTTPS was working today.
No, that's what Arne has set up for Corina.
Aha, okay, that's good.
This workaround.
Oh, thank you. So now I should see the changes, right?
Let's see. We come back here.
Maybe I need to reload the page. No, not really.
I can't see it still.
I mean, neither.
What does it show on your Git? The command line. The Git dash.
It cannot be resolved to branch. I'll try again.
Will you click on branches, Jürgen?
Karin, yeah, I can see a branch. Yeah.
Yeah, it's there.
It's here.
I tried again.
That's good. It worked. Maybe we can
see if I can see it.
Submit a merge request now and see how it gets merged with the rest of.
So where did you see? Oh, no, I see myself also. Yeah. So now I do the merge request. Is that what you're saying?
Mm-hmm. Yeah. So then the other is a bonus exercise.
So is that the git add? No.
No. It's on the Git, the OpenVT. So you have to.
So I don't do it in the Git.
No.
Okay.
You released from the command line now.
Mm-hmm. And I go into my own or
no, it's on the
my own branch and then.
So what you're basically
create merge request or no, you're somewhere else. List.
No, so this is the issues list, and I came here to check your issue number, and that's number 12. And keep that in mind. And now we come to merge request here and say create a new merge request.
Merge requests there.
And then you would get a
new merge request.
Yes, new merge request, and select your branch here. So that would be Karin, and then the target branch is master.
Source branch target. Okay, and then I compare branches and continue.
Mm-hmm. And then when you
do I write something in the description? Number 12? Or?
Yes, in the heading. So if you can say.
Oh, the title should be number 12.
Title should say, maybe give a message. That's the usual way. And then say closes #12 or fixes #12. So that would automatically close your issue. That would that would indicate that this merge request is related to that issue.
And then I do submit merge request.
Yeah, I can see your branch here now.
So I think we can continue, or?
Yeah, it's time, looks like.
And Karen's merge request was already going into the master.
I see it's merged now. Karen is merged to master. Now let's get the master here. See all these files. It's added. It's good to see. If you can please indicate with a yes so that I know you're back, that would be helpful.
We haven't lost anyone in the meantime, so everyone is still there. That's a good sign.
It's a good sign. Yeah, thank you. Yeah, so let's get back to the exercises here. We are at the end of it, and this is the result of our maintainer today, Martin, working hard behind the scenes and merging all the merge requests he got. You can see that you managed to add yourself to the participants list. And these are the files you created. And if you look at the repository graph, you can see how that worked. And I hope that gives you a good idea of how the branches and merge requests work. Well, let's get back to the bash, git bash, and get all these updates back into our local repo. And for that, let's say I go back to master. I say git checkout master, and you can see here the tag changed to master. It means I'm on master now, but I don't think you have to do this to pull, but I say git pull, and the remote repo on OpenVT is called origin by default. So I say git pull from origin and say, as for my password, and says it pulled all these. Now, if you can have your directory open, you can see that you got a copy of the repository online with all the updates that others made. And if you open the README, here you can see the updates made by others. So that was a good work, good teamwork. And last thing I would like to show here for the Git exercise is If you can go to your command line, and you can see that you're on master. I would like to show you what happens if you go back to your branch, and you go back to the branch by saying git checkout and your branch name. And mine was Jobin in this case. I switched to master, and you can see what happened to the working directory. So what basically Git did is Git looked into version history that's stored within the hidden directory here, and reconstructed the working directory from here that was the same state as my branch was when I left it. The branch Jobin was.
Yeah, that is very useful because, for example, if I screw up the model and Johan tries to run it and it's not running, then he can go back and it's very easily trackable what I have changed in the model that caused that it's not running anymore.
Mm-hmm.
So we are trying this out now already for several weeks, months, and it works also quite good in the development process of an FE model.
Yeah. So if you're doing a development, you work on a branch and you do all the development on the branch, and then finally you test the model and see it matches or runs as the model on the master. And then only after you confirm, you submit a merge request. And this to make sure that you don't break anything. And this is how all the open source development happens in the world. Maybe 90% of open source libraries, or maybe 95% of the open source libraries use Git today to version control. So that was a brief overview of Git. Hope you got an idea of the Git workflow. We have just touched the tip of the iceberg, but the good thing with Git is there's a large user community out there, and answer to any of the problems is just a Google search away. So coming back to the Viva Plus repository. You would be able to clone the Viva Plus.
Jobin, I think we lost you.
Yep.
Plus repository in the same, maybe did the exercise. Okay, am I audible now?
Yeah, you're
okay,
audible again.
It shows that my internet connection is unstable.
Yeah, maybe switch off the camera. No,
yeah, I just did that. Maybe I'm good now. Yeah, hope you can hear me. What I wanted to show you was that we maintained the documentation on the same repository, and it's all marked on files, the same as we were working on now. And the documentation is hosted on Read the Docs. If you go to vivaplus.readthedocs.io, I'm going to paste that here in the chat. You'll see the latest version of the documentation. So the documentation is still under construction. We've been focused very much on the model development itself, and we'll be updating the documentations in the coming weeks, coming months. But you get a basic idea of how the documentation for the Viva models would be. We'll have model documentation here, and it would be divided into body regions here. And if you feel like something is missing, you would like to know something more specific, get specific details, please start an issue on the repo, and we'll fix that on priority. And then we would have a contributor guide here. This is also under development, where we would give you resources to work with Git and other guidelines on how to contribute. Yeah, I think that was it from me today. And maybe it's time for dinosaur. Did we have a
or at first, maybe Arne has some more details for the model. If if you have that.
Yeah, I could. How are we doing time-wise?
Yeah, we have 3 minutes left before dinosaur officially starts. So
okay, well, 3 minutes is gonna be tight, but I'm gonna try to hurry. Let me share my screen. So I hope you can see my screen now. Is that correct?
Yeah.
Okay, so we thought it would be good to say a few words about the LGPL license. The LGPL license, the Lesser General Public License, that's the license that we chose for the HBMs and other models developed in virtual. And we chose this license actually not coincidence, but we actually had a lot of thinking in that. And the idea of the LGPL license is that it has a copyleft, actually a strong copyleft, but this is limited to a so-called library. Well, in our case, the library is, so to speak, just the HBM. And so maybe a few words about the fundamental concept, about the copyleft as the fundamental concept of the GPL license, the General Public License, which is one of the most common open source licenses. The idea of the copyleft is essentially you're allowed to use the content license GPL to your convenience. You can do whatever applications you want to do with that. You're explicitly allowed to use it commercially. You're allowed to modify the content. And you're also allowed to redistribute either the original or the modified versions to whosoever you would like. You can publish it on the internet, that's all allowed, provided that any modified or redistributed version is again licensed GPL. That means the copyleft principle basically implies the same license to any modified version of that content until the end of time. So any offspring of the GPL license content will always be licensed. So the LGPL, the Lesser General Public License, now is, so to speak, has a copyleft in a cage. Because again, the same principle holds. You're allowed to use the content, you're allowed to use it commercially, you're allowed to modify the content, and you're allowed to redistribute either the original or any modified versions of the content, provided that any modified or redistributed versions of the content of the actual model are licensed, or it should be LGPL. So the license in heritage only applies to the actual model. So if you now use the model and embed it into a surrounding work, then the surrounding work does not inherit the LGPL license. And that means you can prevent the so-called license contamination of the surrounding work. Because if you include one line of GPL license code into into a big amount of surrounding code, that would automatically all be GPL licensed. And for the LGPL license, the copyleft is always just concentrated on the actual content. So that's now the reason that we chose the LGPL license for our models, because we explicitly want to allow the model to be embedded into surrounding work, such as, for instance, a vehicle model, and that you can do whatever you want to do with that combined work, while always the actual model, the human body model, is always subject to the LGPL license, whereas the surrounding work does not inherit that license. So let's maybe sum up what you may do with this stuff. So you're allowed to use, modify, and redistribute the virtual models under the terms of the LGPL license. That means you're explicitly allowed to use it also also commercially, and you can do any modifications to that, and you can redistribute that to the world, provided that it always remains LGPL licensed.
So that it always has to remain open and unencrypted and
exactly.
shared and open science.
Exactly. So any offspring of that actual model always inherits the LGPL license. So if you take the VIVA model and modify the left arm, then you can give that modified version to whosoever you would like to give it to, just provided that you distribute it under the LGPL license. And you're also allowed to include any of the virtual models into combined work, e.g. a vehicle model. And you're allowed to give that to whosoever you would like to give that to, provided that the actual virtual model is always licensed LGPL. It doesn't matter what happens to the surrounding model. The surrounding model is not affected by the LGPL license, but the part that comes from virtual always has to remain LGPL. And of course, you're, as I said, allowed to use the models commercially. What you may not do, you may not distribute any versions of the virtual models not licensed under LGPL. Particularly, it is not allowed to distribute any versions of the models under a non-disclosure agreement. That means you may not modify the left arm of the VIVA model, sell that to another person and say, yeah, but you're not allowed to redistribute that. This non-disclosure agreement would not be valid because it's against the terms of the LGPL license. And in the same way, you're not allowed to include any of the virtual models into a combined work if the virtual model part is not licensed LGPL. Again, you can make up situations with a non-disclosure agreement which would not work if that applies to the part that actually comes from virtual. And another important point is that the LGPL license always requires you to actually state where the original work comes from. That means if you modify, for instance, the left arm of the VIVA model, then you always have to state that that the original comes from the virtual project. How are we doing time-wise?
It's okay. But I think you gave a very nice overview. We just felt like, as you have received the model now, you should also know what you are allowed to do with the model and what you are not. And one thing also to bear in mind, please, this is just a beta version of the model, and we are kind of in the middle of the development. So please be kind with your feedback, but we appreciate your feedback, of course.
Yeah. Or are there any questions until now? Then if I still have a minute,
yeah.
I could still explain. Actually, the reason that we chose this exact license is because we wanted to cope with two possible conflict scenarios. One scenario is a typical scenario that like an OEM wants to actually test a product with an HBM that comes from virtual or maybe a modified version thereof. And then the OEM would build a combined model comprising the virtual HBM and a car model that's property of the OEM. And now that thing is distributed to a subcontractor with a non-disclosure agreement on the car model. Now this works provided that it is made clear that the non-disclosure agreement only applies to the car model, but not to the HBM. So that would be fine with the LGPL license, because the LGPL license only applies to the modified version of the HBM, but does not affect the car model. And so that is fine, because the LGPL license works, so to speak, in a cage and only applies to the HBM. So that was actually our industry partners took that very much insisted on that this scenario would be excluded. And the other conflict scenario that we had in mind is that actually some company takes the results produced by Virtual, that is our human body models, for instance, on the OpenVT platform. Now they would take that model, modify it, make maybe a better version of that, integrate that into a proprietary model, and then distribute that, sell that to the general public. Now this would not be possible because the proprietary model would automatically inherit the LGPL license. That means actually, well, you could of course sell it, but anyone who buys it would have the right to give it away for free again, because it would still be a licensed LGPL. So those are essentially the thoughts why we chose this license. And we think that's actually a good solution to these problems. Okay, I think.
Thank you, Arne, for stepping in here and preparing last-minute slides.
Yeah.
Yeah, but as we have discussed this a lot, we felt like maybe we should also share our knowledge here with you. We also have a lot of people on the line that worked in Piper and that worked on the VIVA mall, so I think that was a very important step to bring up the idea of the GPL license generally for these kind of things. We just elaborated a bit on that.
Yeah. Okay.
Thanks.
So I stop my screen sharing and
then we go to the last part of the workshop. I hope you're still all awake. And this will be also a bit more, a bit interactive, and we're gonna have another break somewhere in the middle, so that you can have another coffee for those of you where it's, I think it's already quite late. For example, for yeah, for Fusato, how late is it already? Sakosato? Okay, I think quite late. So we just continue. And I would like to at first ask you to again go on the Mentimeter slide, because we are just keen to hear if you have used Dinosaur ever before. So if you could just open that one, that's just interesting for us. We hope that we don't get anyone who says I have used it but will never use it again. Otherwise we have to spend more time now to convince you. Okay. Never heard of it before. That's good. Tried it, was more successful. Okay, we hope that you will be successful today. But oh, another one. So Martin, we should improve the documentation maybe. So we hope that we can help you today to show you the general idea and to make things a bit clearer.
I think you're not sharing your screen.
Easier. I'm not sharing my screen, but it tells me that I'm sharing my screen already.
We don't see the results.
So
okay.
Now.
Ah, okay.
Does it work now? Okay. So 10 of you have voted already, and the majority has heard of it before but haven't used it so far. And we have to convince 2 people that it's not as difficult as it looks from the first from the first view. Okay, so then what we have planned for you today is that we gonna have an example that is a combination of Dinosaur and Jupyter Notebook. And so you will learn how to set up definition files for Dinosaur, how to use the Jupyter Notebook in combination with Dinosaur, and how to use a validation template that we're going to share with you to visualize updated results. So the motivation to develop Dinosaur was that we were quite unhappy after we were running our first human body model results several years back, because we realized that with the commercial products that we have been using so far, it wasn't possible to get the outputs that we were interested in. And therefore, we decided to make our own tool that allows us to have full control of our FE simulation results. So our aim was to have a fast analysis of large results from FE simulation. So all of you who have done already strain analysis from an HBM, you know that these files can get quite big. And the first trials that I was doing, it was always taking me days or at least a night to post-process the results. So we wanted to make that faster. Another big aim that we had is that we wanted to make it comparable. You can read quite often in papers that yeah, someone has analyzed the strains, but you don't know how they were analyzed, which strains were analyzed, where they were analyzed. And the same also goes for some of the criteria and risk curves. So our aim here was to have an open source tool where it's possible to easily share the whole procedures. So ideally, when you write a paper, you can even attach the script that you have used to extract your strains so that everyone can reproduce what you're describing. So that was also the aim, that although we have some license restrictions with some models, that the whole assessment procedures and the calculation procedures can be exchanged very easily among researchers. We're also aiming for the implementation of harmonized injury criteria definitions. So we have implemented some dummy injury criteria like the head injury criteria and so on. But our aim is to go more towards strain-based assessment criteria, but therefore, but specifically try to harmonize the things when it comes to the strain-based assessment, and help researchers to derive risk curves and criteria that can be implemented easily and modified easily with our tools. And it's also possible to use more specific risk curves. So that's also why we have made this special file structure, so that your risk curve can come along with your specific model that you want to use. So our target group here are clearly more the researchers or the scientists, the students, and it's not the most user-friendly tool, how to say it. It's not a colorful GUI for an engineer that is very intuitive to use. It's really more, it's a library. So it is actually a Python library that consists of several different controllers. We are using binary output files from our simulation. So today we're focusing on Alazina only, but also some other codes we are possible to read, and there's some work in progress. And we then have our different files, the object definition file, for example, where we define, where we kind of translate our human body model to the things that we want to analyze. We will come later more in detail to that. Then we do have our calculation procedures that define what we want to analyze and what we want to calculate. And in our controller, the data that we get from the binary output files gets prepared. This is FA code specific, and we transform, for example, the strains into the principal directions for the further calculations. We extract all the data that we need based on the object definition and the calculation procedure definition file. The results that we get are CSV files, or we can also export either MME files, or yeah, you can also add, of course, anything you want to have here, or also visualize some figures. You can see some, we have some messages in the chat. Is there any problem? But I don't see the chat anymore. But Martin, you check if we have a problem, or just interrupt us if anything goes wrong, or if it's difficult to hear me, for example. So let's talk more about these input files that are needed.
There was one question asking, can you also state why you choose to develop another binode reader, then use one that is already available, say QDCA or Lasso. So basically our post-processing tool is using the Lasso library, but especially for the strain and stress-based analysis, we also included further calculation procedures on that. So extracting the principal components of our stresses and strains, and yeah, this is where the real power comes into play, I would say.
Yeah, so the binode reader, so we clearly have an expert here that comes from Lasso. It's also acknowledged in the code, and that's the nice thing about open source software, that you can combine things here. So we use the Lasso library to extract our data from the binary output file, but then afterwards the data handling, let's call it like that, that's then really the dinosaur specific part.
Yeah, exactly. For instance, if you take the rip fracture criteria,
yeah,
then you have to do further calculation than just using that. And so we also wanted to harmonize the calculation method in there as well.
Yeah.
Hope that answered it. And what software do you use for visual inspection of simulation results?
So for visual inspection, that's not something that we do with Dinosaur currently. So we still use any other post-processing tools. I think there is also one tool from Lasso that we tried out to make visualizations with the different plots. But Dinosaur has developed a bit, so while it was more a GUI-based tool at the very early stage, it became now really more a scripting thing, and really a library where we focus especially on the calculation procedures itself. And so we didn't put any focus anymore on the visualizations.
And what also comes into play here, because the Lasso library is meant for LS-DYNA outputs, but we also want to include input reading functions for MADIMO simulations as well as for VPS simulations.
And hopefully other codes as well in the future. But it was very helpful to have that, because also, to be honest, at first we started without the Lasso library and we read the LOUT files, but that was really painful because it took us much longer. So this was a big advantage that we made. And I think that's one of the examples how fruitful the open source community can be.
Yeah.
Okay, please feel free to add additional questions if you have some. I just have problems to read them here directly, but Martin will always have a look on the other screen. Or otherwise just unmute yourself and speak out. We're not so many people, so that's also fine. So those of you who have tried it but had some problems might have had problems, especially with setting up these input files. So we do have two different, but they do look much more complicated than they are. And the good thing is, with the VIVA models, you will get the complete VIVA Plus models. You will get the complete set of files that can be used directly, so you don't have to set anything up by yourself. You can start with these things that you receive from us.
Hi, Corina, I have a question. Kavi here. I do have like one question. I think the most important thing when it comes to open source models is like a good documentation of what is being implemented. And I tried using Dinosaur like a month back, so quite recently, and I could not find, unfortunately, something which I was searching for, and the documentation, it's actually not that great. So do you have any timeline on when you plan on doing that, or can you like update us on how that would be done?
If you find something that you cannot find in the documentation, then the easiest thing is that you just provide us with an issue, and then we can elaborate on that, because otherwise it's difficult for us to know what is missing. So if you see something or if you think that something should be added in the wiki, I hope that you found the wiki.
I mean, generally the code.
You mean generally the code? Yeah, our main focus on the documentation was to explain what the different models are doing, and that's what we explain in the wiki itself. And the rest we try to make the code easily readable. But if you really want to change something in the code, and if you have some specific questions on that, then just post an issue on the GitLab board, and then we will try to address that as soon as possible.
Okay, thanks.
Yeah, so coming back to the object definition file. So the aim of this file is to name what is included in my model and which names do I want to use as an identifier. Because we have different models, the IDs are changing, but we always have, for example, an impactor, we always have an head COG. So our idea was to make this kind of conversion file that allows us to also use multiple models or models with changing IDs. And we just have to write this kind of vocabulary file that tells us, for example, here that the node with the ID 900,000,000,1801 is the node that belongs to our impactor. When we look into the calculation procedures, then the question that we answered there is which output should be extracted and which calculation should be performed. So, for example, here, if we want to analyze the x displacement as a function of time from our impactor, then we generate this channel that consists of an x and a y channel, and we specifically define that our x channel should be the time and our y channel should be displacement. And here we don't need any node ID anymore because we just always refer to impactor, and Dinosaur knows then that the impactor refers to this node ID. This is a very simple example, as you can imagine, but we felt like maybe it's easier to understand the file structure as such. You can also have as an object, for example, your brain, and then you make a list of all the parts that belong to the brain. And when you want to make a strain analysis, then you just have to fill in here, I want to make a CSDM. I want to calculate the CSDM for my whole object brain, or maybe I just want to calculate the maximum principal strain of the corpus callosum region. Then I have to define that as a specific object here, which I can then also refer to on the right-hand side in my calculation procedures. So the idea is also that this file, the calculation procedures, can be always easily exchanged. Here for some models we have IP restrictions, which is why not everything can be shared, but for the VIVA Plus models you will get both files ready prepared for you to perform the analysis. Yeah, so here you just see that these are the things that are in common. This is the connection between the two files. So we have a node and we have the impactor.
This defines the ID that we are using internally for having it in the controller.
And if we want to draw it in the notebook. Okay, so Dinosaur, as said, it's a Python library. The documentation how to use the library is available on the GitLab wiki. And if, as before, if there's anything that you're missing, then just let us know. But the documentation really focuses on someone who wants to use the code. You can easily write, therefore, any assessment scripts in Python. You can import the Dinosaur control classes into your framework. You can extend the definition files to your needs, because what we were saying at the institute is, because Martin is the guy who studied computer science, but we are all more mechanical engineers. So he's doing the thing really the controller classes, while we are adjusting more or less the calculation procedures, and that's something that's very easy to program because it's just a JSON file, and we can just program our Python code around it to perform the analysis that we want to. And one way how we are using it is to use a Jupyter notebook for the scripting and visualization, because it's nice because we have the scripting and the visualization at one place. So it goes more into the direction of something with a GUI, but it's an interactive notebook where you can put in your Python code, you can execute that one, and then you directly have your visualizations in there. So if you want to have a template here, then you can easily post-process other simulation results in a comparable way, and yeah, have again a very user-friendly way of how to look into the results. Yeah, as said, it's a combination of documentation and script. It's interactive computing. So if you later on see the file, it looks like a website, but it's actually really also a command line programming that it can do in the different cells. Martin will show this to you later on. You can use it for dozens of programming languages, but we will just focus on IPython because we just want to use Python because Dinosaur is a Python library. But we use the notebook to access the Dinosaur modules and perform the calculations that we want to do. So the aim is that we have harmonized, transparent validation reports, because our vision here is that if you have now the VIVA plus models and you want to change anything in the model, and then you rerun the validation load cases that we are going to provide together with the model. But then we need a harmonized way to look into our results, and therefore we want to use Jupyter as, yeah, we think that this perfectly fulfills our requirements here and will allow that we all look into our results in a similar way. And if you then later on send a merge request, then we will have the notebooks check if the model gets better or worse, and then we can decide if the merge request gets accepted or not. And now I would just quickly hand over to Martin so that he can just show you how this looks like so that you get a clearer picture of what I was talking about before.
So basically what you should have already set up your Python environment. That's something.
Sorry, Martin, you sound very distant.
Okay, let us try something else.
Otherwise you can.
The cable is too short, but I will figure something out.
Okay, I hope it's better now. Maybe some feedback on that.
Yes, it sounds good now.
Okay. So basically you should have received some instruction of how to set up your Python environment or the VIVA plus post processing. And yeah, as we're working on the Windows, we are using Anaconda. And I'm just starting the Anaconda prompt now. You see my screen? I hope so.
Yeah.
Yeah, it works.
Okay, and now, so you should have checked out maybe the workshop exercise. And you can also do that or changing into that directory within the Anaconda prompt. And I'm doing that now. So I have it under temp and then workshop exercise. And then I activate the Python environment that we created. I just have a look what we have installed on the list. It's a bit slow. Yeah, and now I'm activate the VIVA workshop environment, and this should have already installed Jupyter Notebook if you have followed the instructions. And now I can open that, and it opens a server on localhost, and that server, yeah, is just showing me the file tree in here. And I'm going to post-processing, and this is the Jupyter Notebook dashboard. And I'm starting a new file. This will open a new tab. And now there are two options with Jupyter, as Corina already told us before. So it's basically capable to do some kind of documentations, or maybe let's call that header. And for that one, that two. And yeah, you can do that in Markdown. That's something that Jobin has shown you before. And if you go to run, that should be executed. So that's something that you can do interactively. But you also have the possibility to write Python code directly. So if we have the general coding example, print hello world, then this should be executable. That's one thing that is possible. So you can either code and also document what you're doing. That could be very helpful for also visualizing your results and doing stuff like that. And you can also integrate other Python libraries, for instance, NumPy. If you run that, it takes a bit, but then NumPy is imported, and you can, I don't know, create an array or something. NumPy array 1, 2. That's pretty similar to, or NumPy is a library that allows you to do nice math calculations, as you maybe are used to in MATLAB, and that's the Python Ponton. But you can also, if you have installed Dinosaur, also import Dinosaur directly. And yeah, this gives you basically the possibilities to use the controller classes as Corina has described it before. So so with the example that I have given you, or that we have given you recently before the workshop, you could have checked whether the Jupyter setup worked for you. So maybe the question for you guys, how good did that work, or are there any problems? Did you get some kernel errors or any other errors while trying to do something like that? So maybe we can have also raising hands if that works for you.
So if we don't get a red flag, we assume it's working for everyone. But Martin, can you maybe just show how people can try it out again?
Yeah, sure. So I'm shutting down the server now and starting it again. So basically what you have to do is, yeah, you can switch to your, you have to activate the VIVA workshop environment.
You have a typo.
Yeah. And maybe change into the directory of your Git repository. So the workshop exercise where you just worked before. And then you can start a server of the Jupyter notebook. And this will open a new browser tab with the Jupyter notebook dashboard. Maybe it asks you in which browser you want to start, then select your default or whatever you prefer. And then you can basically create a new example file or a new notebook. And then it should give you something like that. And then you can write print or write in hello world and run that.
As it's now time again for another break, maybe you can just go back to the other notebook and just try if that one runs. We will stay here if you have any problems. Or otherwise, you can also just play around with the existing notebook.
Yeah, that's the one we created before, the one that I showed you.
I think someone else started to share the screen. Maybe you can try again. Yeah, perfect. Okay, then we're gonna meet again in 10 minutes, so at 15 minutes past 4 Central European summertime. And then we're gonna show you the example that we have handed out, and then we can try out some things with that one, and you can also access the handout.
May I talk?
Yeah, sure.
Okay. Yesterday I had this kernel error problem, and then I reinstalled it with the new environment and the new Python version yesterday.
Yeah.
And now I switched to the new environment, but
Yeah.
I still get the same error. I don't know why. Yesterday it worked, but now it doesn't work anymore.
Okay.
Do you have any idea?
Maybe you activated the old environment again instead of the new one?
No, I have VIVA Workshop Python 3.7.
Okay.
I activated this one. Or can it be that I have activated 2? No, I don't think so. It's just 1, right? I'm not sure if I tried it before because I had an okay, I had saved the Jupyter notebook. This could be the old one. If I had everything running and I have an I use the start menu with Jupyter notebook, which one is used? Do you have any idea?
Do you can we actually maybe see your screen or something? Maybe we can fix it online.
I can, yes, I can do so. Oh, one moment.
Otherwise, we would also have a backup solution for that.
Okay, I'm showing you my screen right now. Okay.
Yeah.
This is what I did here, and if I go back, I activated VIVA workshop, then I changed to the directory, and I started the Jupyter notebook.
But it said that it couldn't find this environment, or if you scroll up, then it said,
oh,
didn't activate.
Okay, you have 2 underscores here, if I'm right.
It's just a typo.
So you're still, can you see that in
Yeah, I see it. I tried to change it.
Yeah.
Okay.
That looks better.
Jupyter notebook. Yeah, I copied it and therefore, but I copied it in 2 steps.
Okay.
But I still run. I see the dinosaur error.
Can you run it again?
I run it. Now it's okay. I need to run it 3 times, right? Anyway, it doesn't matter. Now it's functioning. Okay.
Or maybe can you run the next one as well, because then it should give you another location than home Martin documents. Yeah, it's your location here. If you have a look on the
yeah, it's here. It's in the Python 3.7. Okay.
Yeah.
Okay, thanks.
Otherwise, there would be also another option for maybe if someone else has a problem with that. We also put the workshop exercise on our GitLab.
I stop my screen.
Yeah, then
for
I
you to
share it again. So if someone in the meanwhile also or still has troubles to launch Jupyter Notebook, there would also be the possibility to launch an online version of it, so it's not hosted on your local server.
Okay.
In that case, it's or the whole environment is set up somewhere different, and then you can also play around with that notebook.
Okay.
Which would be.
So with the functioning notebook, I'm set up for the next exercise, right?
Yeah, you're perfectly prepared now.
Okay, thanks, Corina. Okay, so here you again.
Yeah.
I think we should get started again so that we can finish on time. I hope that you're all back. I have sent out in the meantime in the chat a link to the handout. So similar as you have had it for Jobin, you also have a handout here that you can follow to, yeah, so that you don't have to type in what Martin is showing on the screen, but you can just copy paste. I think that's the biggest advantage of using the directly the handout. Okay. So now we would have a look into this notebook that we have shared with you that you can see on Martin's screen. You can find again in the handout a brief explanation how you can do that. It's the one that you can find in the post-processing directory of the workshop material.
So we have here our repository that was just extended beforehand by all your contributions. And we, beforehand or before the workshop, we also placed a directory in there, which is called post-processing. And in there we have that Jupyter notebook file. And yeah, we were running the server in here. And as shown before, it's a bit tricky because the
Zoom task
bar is always
in the way,
interrupting me. Yeah, I switched into that directory, started the Jupyter notebook server, and now I'm already running the notebook, and this is shown here. So if you do the same, it should also give you a view like that in a new tab. Yeah, I already told that before. There's also a backup solution I posted. If it does work, you can also try to run the link that I posted in the chat. It's a solution where the entire environment is set up on a server, hosted somewhere different, and yeah, should do basically the same as your local server. So yeah, the notebook itself is contains some markdown cells. As Johan already told you before, there are some possibilities to do the documentation, to have a nice structure on that, and to also include
pictures
like that here, explaining what dinosaur is and what it does, and the imports of the necessary libraries. And so we have OS, or the import of OS, that is basically giving us some possibilities to play around with OS functionalities, like listing the content of a current directory and stuff like that. And also NumPy and our matplotlib library, which you can plot your results, and also the dinosaur classes that we imported. So, as already indicated, we have two different controller classes which you can use. The first one is the criteria controller class, and the second one is called the data visualization controller. And for both of those classes, you need, if you want to use them, you have to provide some additional data. The first thing that you have to provide is the location of your pinout file, so that's that one, and also the the location of your definition ID or the object ID files and the calculation procedure IDs. So that's the thing that we need in here. That's the thing that we also declared in here above. So just connecting some file locations, and then we pass that to the controller class. And if we run that, then you can also see that we did not import, I think, that one. So now it should be able to do that. You can see that in the first steps, the calculation procedures are read in, then the objects are read in, and then based on what we have defined in here, the data is extracted. So, yeah.
Yeah, so basically you don't have to change these lines, you just have to change your path if you want to apply it as a user. It just tells you, yeah, it's just the preparation for the funny part that comes now.
Okay, so if you can do that, if that works for you, so it's just some kind of definition, then you can use the data visualization controller, and this is basically extracting something like a diagram for you. So in this case, we have defined the contact force impact to HPM of the impactor, and there the X velocity, and that's over time.
Yeah. So that's just everything that is really a channel, so a time series that one is controlled by the data visualization. If you just have one value, like an HIC or like a maximum of acceleration, that one we are going to control with the criteria, because those two these are the only two types of control that we have basically in Dinosaur, because they need different data handling. If you have for example, a CSDM calculation, that's the criteria. If you want to calculate your, or if you want to apply a CFC filter on a specific acceleration, that's all in the data visualization.
Okay, so the visualization controller that we have defined up here has the property that you can do some calculations, and this is defined through the through some kind of dictionary that you pass to it, and that can be extended as well. So we have just a bunch of different commands for the things that we want to extract from our data. So we run that, and if everything works, then yeah, if everything is properly defined, then we have all those data available, and this can be extracted through the get data method. So you have your data visualization controller again, and then get data from the impactor that's defined here, and the impactor acceleration in X direction that's defined in here. And now we want to, now we've defined a variable because we have extracted the time in here, and then we can do some further things with it. So if we type in, for instance, so I messed something up. Print time. Then you also have the time steps that were extracted from the data. So far so good. And now
and these are all just Python commands combined with the Dinosaur routines. But that's all very, very easy, and you can look that up everywhere. And basically, if you have it here once, then you can just combine it and expand it as you need it.
Yeah, exactly. That's what is the nice thing about it. Here we included some plots from what we get, so the time over the contact force, and then we just visualized it here. A further thing that we can do is writing things into a CSV file. We've defined an output directory beforehand, and if you have those examples, then there should be an output file, and from what we had, or from what we defined, or from our list of data extractions, which are here, we have just written everything to a CSV file.
Which can be specifically practical if you have a big simulation file and you extract a lot of strains, then maybe you don't want to do that over and over again. Then it can be useful to extract the CSV where you have that collected.
Yeah.
Which you can then, of course, import again into your Jupyter notebook if you need to. You don't have to access it from the bin-out. You can also access it from the CSV, which is what we're going to do in one of the next steps, or exactly in the next step.
Yeah, exactly. That one brings me to the actually aim of what we want to do with that Jupyter notebook in particular.
Yeah, so the exemplary simulation results that you see here are we are just in the middle of the validations of the VIVA Plus model, as you have heard earlier from Johan. And so this is an example of a Viano validation that we were running. So you might have, or the majority might have seen them, that these are lateral impacts with a close to rigid impactor. Here it is an impact at the hip area. And our aim is to compare the curves from our simulation with the experimental data. And that's what we do here now in the next step. So we import our data from the literature, from the experiments. We save them earlier in a CSV file, and we have different corridors. We have a corridor for speed 1 and a corridor for speed 2 because they were tested at multiple speeds. And we import that from the CSV file. And after that,
we can show that. So we have here our bin-out files that we just defined before. So our different simulations are located in here. And then we have
our auxiliaries, that's how we call them. For example, here the pelvis file. It's not the nicest file. We just wanted to have something to show it to you, so I don't want them. Yeah, but it consists of force deflection and force time curves that we are going to plot now and compare it with our simulation results. Sorry, a kid is crying in front of our window. I don't know if you hear that. So yeah, that's what we do now here. So we plot now our experimental results against the simulation results. So you can see then in the diagram here, the orange line is the corridor that we have from our experiments, from the literature, and the blue response is the one that we got from our VIVA model at that stage when we were running the simulations. And the first one is the contact force as a function of time, and the other one is now the contact force as a function of the displacement. And you can see that we are good at the beginning, but then we are too soft, so we're not in the corridor, but this should be also just an example, and the model is still under development. However, it's important when we look into simulations, and that's also something that we want to highlight. Most of you might anyway know, but it's not something that everyone does. That it's also important to check the quality criteria, and that's what we do as the next step. But Martin made a break here because I guess you want to show something. But it's just the general settings that you can see here. So you can use whatever name you want. You can change the color. You can change the grids. That's just matplotlib settings that are very easy to look up, and yeah, that you can modify however you want it. But
I think it's nice because you can later on easily always see what you did, but on the other hand, you also have the visualization directly. So for example, if you see that the curve needs to be scaled, then I can scale the curve with 100, or I don't know. Here I have, for example, a scaling factor included, because that is I use the acceleration and then I multiplied with the mass of the impactor. But for example, if I realize that this was the wrong mass and I multiplied with 30, then I get a new curve, but I never have to wonder which mass I used because it's directly up there. And I could even, if I would have spent more time, I would have even maybe defined a variable that's called mass impactor, and then I just have to change this value. Yeah, and what we have also included in this template, as said before, are quality criteria. So for example, we have the total internal kinetic energy versus the time, which is shown here as one of the next plots. And also here, it's always a very similar similar code, as you can see. You can spend more time and define your matrices so that you don't mix up units and the labels, or you do it manually as we did it here, for example. So we see also the different energies. We see the internal hourglass energy versus time. That's another plot that we felt is always useful. And the idea is that whenever you provide the validation, that these things have to be included, because it's something that we want to check to see, to also check the numerical issues in the model. So here, for example, we would not be so confident about this result because we do have a very high hourglass energy, much higher than our internal energy. So we know that we should look again into the model and see what's going on here, because it would be not a proper validation. We can also print the whole channel, so we can not only visualize them, we can also, if we want to access the numbers, which can be also useful to maybe double check, for example, criteria or something like that. Then we can also plot our channels, which is what you can see here. And yeah, furthermore, I've mentioned it before, we don't only have the possibility to use time channels, we can also use criteria. So for example, here we use the maximum hourglass energy, the maximum added mass, the ratio of our hourglass energy versus the internal energy, the difference between our master and slave contact force. So the maximum of our difference of the master and slave contact force between the impactor and the HPM. And also the percentage of increase of our added mass. This is, of course, a list that can be further extended. This is just our starting point, but these are the things that we are checking throughout all our validations currently. And as this is now, these are now criteria and not time channels, we decided to visualize them in a table, which is, of course, also possible. And done in the lines that you see here below. And finally, we can save all our figures as well as the table as a PDF that can be then easily shared or also stored together with the simulation results. Okay, so the exercise would be now that you try to change the path to another output file, because you might have seen, Martin, if you can open that one again, that we haven't supported you only with one set of pinot files. So we have the Viano pelvis high speed, but we also have one other example with an adjusted flash material. And yeah, maybe you can try to adjust your Jupyter notebook so that you can visualize now the results from the other directory. And please just let us know if you need any help by raising your hand. Yeah.
And otherwise, just click on the.
Are you all still there? Yeah, and maybe post then your observations on Mentimeter. We haven't received any answers so far. One tip is that you can also click on these double arrows, so then all cells get run again. That can be also very practical. Yeah, so this one. Then you don't have to run it cell by cell, although it's of course interesting to see cell by cell what's happening. Yeah, it's a shorter simulation time. That's true. Anything else? Yeah, the force is now within the corridor. But if you look into the energy balance, you will see that we were still not happy. So it was just another iteration. So we have 2 people that are indicating that they have been able to complete that. What about the rest? You gave up? It was already too long, or? Yeah, you can also try on your own later on. You have the handout. There are also some more exercises included there, which we felt are practical or are a good way to get started with that. You also have in your directory the dinosaur files that we explained before. Someone wants to say something?
Maybe they're going to do it as homework.
Yeah. So there is, you also have now this object.def and calculation procedure.def in your auxiliary directory. they are very easy because we felt like it might be easier to start with a very clean structure with very easy things in there. However, the main functionalities are included, so they just have to be extended. And later on throughout the project, you will anyway also receive more enhanced files from our side for the VIVA Plus model, for the different validation load cases, which are now growing one by one, and which will be shared together with them all, because we think that this is important when a community of people wants to improve the model. We still have the wrong mass in here.
Was it that?
Yeah. Yeah, this curve looks better, but the energy still looks bad. So work in progress. Okay, so anything we forgot to mention about the Jupyter? Otherwise, we should conclude the workshop, I think. Jobin, you wanted to add something?
Yeah, maybe we could mention that we are available for support on Zulip. That's where the user community is. So if you have any questions regarding VIVA Plus or Dinosaur, you're welcome to post your questions on Zulip. So we have a channel called VIVA Plus beta users. Maybe I can show that on my screen. Yeah, we have a channel called Plus Beta Users where you can post your questions. Or we have a channel for post-processing. This app is like Slack, but maybe an open source version of it. Yeah, we'll be more than happy to answer your questions.
Okay, yeah, that is a perfect transition for the take-home message, I think, Jobin, because now I'm gonna share my screen again. So the main message that we wanted to give you for today is that everyone is welcome to contribute. So together we can make this model really successful and good, and we can make the advantage of this open source, completely open source model. So there are different types of contributions that are welcome. So just report an issue when you encounter something while you're running the model, or maybe also report an issue when you feel that something is missing in the documentation. Join the users community at Zulip that Jobin has just showed us. Learn something, find help, and give help. So we are all really open-minded, and we are all happy to help you out whenever you encounter any problem. And the idea of Zulip is then also to have kind of a forum that things that you can, it's also searchable, and you can look for things that others might have encountered previously. We would be more than happy if you use the model that you have received today to run validation cases, to post-process them with Jupyter and Dinosaur, to elaborate on that, to if you have some additional comments on things that we should add into our templates, or if you have some ideas on additional outputs that should be included into post-processing templates, then just let us know. Push model or documentation updates. So you have learned today, hopefully, that this is not as difficult as sometimes some people think. So Git is really helpful for developing a model together, especially in Corona times when it's not possible to meet each other. We have made quite a big advantage of that. And it's very useful for us to maintain the model. So if you would like to try out a different material model or component, feel free to do so. we would be happy if you then give us the feedback and push your material more so that we can also use it in the model. Introduce new features in the model. This can be just another node for the output that is useful, or some additional joint characteristics or an additional context that you think might be useful, or whatever you can imagine. Of course, Johan has mentioned that at the very beginning, we tried to make a model with material models that we hope can be transferred to other FE codes. So if you are a user of another FE code and you're interested to translate it, then please feel free to do so. Just one small comment, maybe just wait another year before you do the whole translation, because the model is still changing a lot currently. Update the documentation also there. If you find something out, just fill it in, or if you cannot find something, report that as an issue. We hope that although it's more difficult to make such a workshop online than in person, that we were able to give you a brief overview on our ideas and on their tools that we are currently working on to develop our model, and that you have fun with trying them out then also at home and later on. At the end, we would be happy if you provide us with your feedback by just filling in a last Menti survey. It's still the same link as we had before. And the first thing is that we would like to get to know if this workshop was useful for you, and if you would be interested to participate in future workshop or even in a hackathon. So Jobin has this idea of a hackathon that we could do in the future, where we could have all work together on a common aim in a limited time period. So yeah, it would be cool if you just take another 2 minutes to fill that in, and so that we can see. Okay, many things remained open. So does that mean you will be interested in joining another workshop, or was did we put too many things into the workshop? Difficult to follow. The person who has answered that, then please feel free to contact us later on. We will be happy to help you. We could, as said at the beginning, we didn't want to frustrate people. We if it wasn't possible for you to follow, then we would like to help you so that you can try it with the handout on your own, in your own pace. Okay, and then we will be interested what topic for a next workshop should be. So because some of you said a lot of things remained open, so do you have any ideas on what we should do the next time? Should we have one workshop focusing on Git only, one workshop focusing on the model only, one with more focus on Git and Dinosaur? However, I think there we have explained maybe already everything that is to explain. No, of course, it's always possible to do more. About the model only, okay. Because our idea was to start with this common workshop where we have all the topics included, and then go more into the details in future workshops. Any more ideas? Coffee. Yeah, I'm unfortunately not an expert in coffee, but I'm sure we can find someone. Cost benefit analysis tool. Okay, that's David will be very happy to hear that.
Yeah.
protocols. Yeah, we're working on that. Okay, yeah, so thanks a lot for that. Feel free to send us also messages afterwards. And from my side, that's it. And I wish you a nice remaining day or night or evening, wherever you are, and hope to see you soon again, maybe hopefully even in person at some point. Thank you.
Thank you, and we will be happy to stay back for a few minutes if you have any questions or comments. But otherwise,
thank you very much. That was excellent.
Thank you. Thank you. Good to know that.
Thank you all for participating.
Hi guys, would you be sharing the recording? Or?
I can hear you, but very quiet.
I just wanted to ask if you would be sharing the recording.
Yeah, I think so.
Super, thanks.
Well, we might have to cut it because I always forgot to to press on break while we were in the breaks.
Yeah.